What's up, guys? It's me, Sir Ernest, and today we're going to apply the acceleration and velocity in plane polar coordinate system and see if it is consistent to uniform circular motion. Okay, so here, for instance, the particle is moving in a uniform circular motion. So that is r is a constant. Also, we know that the speed of your particle is also a constant, though the velocity is not. Because remember that velocity changes direction as the particle moves around in a circle. Like this. Okay? So, let's recall that the velocity as a function of time in plane polar coordinates is given by r dot r hat plus r theta dot theta hat, and the acceleration is given by r double dot minus r theta dot squared r hat plus r theta double dot plus 2 r dot theta dot theta hat. Because we already know that r is constant because it's moving in a circular path and the velocity and the speed is uniform. So this means that r dot and v dot and theta dot are both equal to 0. Because remember that v is equal to r theta dot. And this is equal to a constant. Okay? So that means this is 0. This is 0. This is 0. And this is 0. So what is now left is v is equal to r theta dot theta hat. So that means the velocity is always transverse. There's no radial component. And the acceleration is always in the radial component. So this is negative r theta squared dot, or r theta dot squared r hat. So a is always negative r hat. So that means this always points toward the center. And velocity is always perpendicular, as we already know earlier. Now, to make this more familiar to everyone, because remember that v is r theta dot, so therefore this can now be equal to v equals v theta hat. Again, theta hat is says that v is always perpendicular to r, and your a is equal to negative if this is v squared, this is r squared, theta dot squared. So this is theta dot squared r is equal to v squared over r. So this is a will now be equal to negative v squared over r hat. And this is the more familiar terms for velocity and a. Okay? So you will notice again that the velocity and acceleration are both constant in magnitude. The velocity is always perpendicular to r, and a is always opposite the direction of r hat. So this is your transverse velocity, and this is your centripetal. Sometimes we call this your radial because it's always pointing along the radial direction but opposite. So this is centripetal or radial acceleration. Okay, so this goes to show that we can express the velocity and acceleration for uniform circular motion through the plane polar coordinate system. Okay, so that's it. Thank you for watching, and I'll see you guys in the next video. I hope you learned something today, and take care. Bye bye.